There are three forms of a quadratic equation, but in this video we're going to take some time to review two of them that we've seen before. One is standard form and the second is factored form. An example of an equation in standard form could be shown as y equals 2x squared minus 2x minus 24. So basically the general format for something in standard form is y equals 8x squared plus bx plus c. Now, in terms of the information that we can take from an equation in standard form, specifically the a value and the c value tell us some of the key features or key properties of a quadratic equation from standard form. The a value, which is the number located in front of the x squared, tells us the direction of opening of our parabola. If you have a positive a value, then your parabola will open up. When your parabola opens up, it takes on a U-shaped form. If your a value is a negative number, then the parabola will open down. And when it opens down, it just looks like an upside down U, like so. The c value, or the outside number of your standard form equation, so it's typically the number that is by itself, doesn't have any variables attached to it, that number represents your y-intercept. If you are given an equation in standard form, but you want to convert it into factored form, you could simply take your quadratic equation and factor it. And there are three different methods of factoring. You could choose to use common factoring, the product and sum method, or the difference of squares method. The template for an equation in factored form looks like y equals a multiplied by x minus s multiplied by x minus t. From a quadratic equation in factored form, there are again two key pieces of information that we can take away from factored form. Again, we still see the same letter a at the front of our equation, and just like in standard form, the a value tells you the direction of opening. So that's going to tell you if your parabola opens upwards or downwards. If your a value is positive, the parabola opens upwards. If the a value is negative, the parabola will open downwards. S and T represent your X intercepts. And there are lots of different names that are used in math for X intercepts, specifically when we are talking about quadratic equations. They could also be called the zeros, or they could also be called the roots. Once you know the S and T values, or the values of your X intercepts, you could also then calculate another piece of information for a parabola called the Axis of Symmetry. This is where you will be able to cut your parabola in two equal pieces, or exactly in half. The formula for calculating the Axis of Symmetry is x equals s plus t divided by 2. Something to take note of about the axis of symmetry is that the value of the axis of symmetry is also the x value of your vertex. So it is half the value of your vertex. In order to find the corresponding y value of your vertex, you could take your axis of symmetry value and substitute it back into your original quadratic equation. If you wanted to take an equation that was in factored form and you wanted to turn it back into standard form, you then could use the process of expanding called the FOIL method. So let's see if we can remember how to graph a quadratic equation. We have an equation here, y equals negative 2x squared plus 12x minus 16. We're asked to graph this equation with an accurate vertex and zeros. So this is an equation that's given to us in standard form. But in order to graph accurately with features such as a vertex or zeros, we're going to need to take this equation in standard form and turn it into factored form. The only way to do that is to attempt to factor this equation. The first step to factoring is to always check for a common factor. So we're looking for a number that can divide evenly amongst 2, 12, and 16. The only number that would divide evenly amongst those three values would be a 2. Something else that I noticed is that there is a negative here in the front of the equation. So not only am I going to common factor out a 2, but I'm also going to factor the negative out with that 2. So what I'm going to do is I'm going to divide all three of these terms by negative 2. Negative 2 is my common factor. So when I rewrite my newly factored equation, I need to include that common factor right at the front of my equation. I'm then going to open up a bracket, and inside that bracket, I'm going to write what's left over once I complete these division steps. So negative 2x squared divided by negative 2 is going to leave me with x squared. 12x divided by negative 2 is going to leave me with negative 6x, and negative 16 divided by negative 2 is going to leave me with a positive 8. So we've done as much common factoring as we could. The next step is to look at the portion that is inside of the bracket, and we are going to see now if this portion or this equation can be factored even further using one of the other two methods of factoring. So the next method you should check for is to see if this can be factored using product and sum, or the product and sum method. So what that means is we need to look for two numbers that will multiply to give us 8, or the C value. Those same two numbers need to be able to add together to give us negative 6, or our B value. So using a little mental math, I know that negative 4 multiplied by negative 2 will give me a positive 8, and that's the number that we're looking for our C value. And if I take negative 4 and add negative 2, that's going to give me negative 6, and that's our B value, or the middle number in our equation. So this equation is still factorable, and those missing or mystery factors that we're going to use are negative 4 and negative 2. So to write that answer, we're going to keep the y, we're going to keep our common factor of negative 2 that we had pulled out previously, and we're going to now create two smaller sets of brackets. We are using the variable x, so we're going to insert an x into each bracket, and then we're going to put in those two mystery numbers that we came up with. So one of those values was negative 4, and the other value was a negative 2. So now this equation is fully factored. The next thing we need to do is now actually solve for the x intercepts, or remember that another term for x intercept is the word zeros. In order to solve for these zeros, we need to take each of these factors that we just created, and we need to set them equal to 0. My first factor is x minus 4, and I'm going to set that equal to 0. And now it's just a matter of solving or isolating for x. So to do that, I'm going to take this negative 4 and bring it over to the right-hand side. That's going to leave me with x equals 4. So this is one of my x intercepts. I'm going to do the exact same thing with my second factor of x minus 2. I'm going to set that equal to 0. Again, I'm going to bring this negative 2 over to the right-hand side, and that's going to leave me with an answer of x equals positive 2. This is my second x intercept. So we've calculated our zeros. The last thing that we need to determine is the vertex. So remember from our previous slide, we can find half of the vertex by using the equation for the axis of symmetry. the equation for the axis of symmetry is x is equal to s plus t divided by 2. Remember that s and t are basically just your x-intercepts that you just calculated. So we're going to insert those numbers into our equation. So we've got 4 plus 2 all divided by 2. So 4 plus 2 is 6, and 6 divided by 2 is 3. So my axis of symmetry is 3, or half of my vertex is located at an x value of 3. Remember that a vertex is also made up of a y value. So in order to find that corresponding y value, I'm going to take this x value and I'm going to plug it back into my equation. Now you have a couple of options at this point. You could take your x value and plug it back into the original equation. You could plug it back into our half-factored equation, or you could plug it into your final factored form of our quadratic equation. It doesn't matter which equation you choose, you should get the same answer regardless. So I've chosen to plug in my x value into the fully factored form of our equation. So what this tells me now is that everywhere I see the letter x, I'm going to plug in our answer of 3. So in our first bracket, we have 3 minus 4, which is -1. And in our second bracket, we have 3 minus 2, which is a +1. And then it's simply just a multiplication. -2 multiplied by -1, that is a +2, multiplied by another 1, it's still +2. So our y value is 2. If we were to put these two numbers together, our vertex is located at 3 and 2. Now that we've gotten our vertex and both of our values for the x-intercepts, we can take those points and plot them onto our Cartesian plane. So our vertex was located at 3 and 2. So I'm going to take my pen and I'm going to put a dot or a point on my vertex of 3 and 2. So I've gone ahead and placed a dot on my vertex. Next, I'm going to place dots on the x-intercept values. So one of them was located at +4. So on my x-axis, I'm going to put a point on 4. The other x-intercept was located at 2. Once I've plotted those 3 points, I can go ahead and connect them together with a smooth curve. Remember that your parabola is either going to open upwards or downwards. If your parabola opens upwards, it should be taking on kind of a U-shaped form. But if your parabola is opening downwards, it's going to take on an upside down U shape. Now, before I go ahead and join my points together, if we wanted to, we could go back to our original equation and check the a value, or the sign of the a value. Remember, the a value is the number that is located right in front of the equation. It is also always attached to the x squared term. So when I look at my a value, I see that it is negative. It's actually -2. Remember that a negative a value tells you that your parabola should be opening down. So if I go back and look at the points that I've plotted, it only logically makes sense that I connect them so that my parabola opens down. So I'm going to really roughly join them together and put little arrowheads, and there's my very tiny parabola that is opening downwards.